Okay, of course, Monday, school's closed. So anytime there's a holiday, you'll find that they lock down the school. It's open on the weekends. I think it's open from 7 till 9 at night, but anytime it's an official holiday, they close it down. So if you need something in the labs, do it Saturday and Sunday. I want to go over Lab 6 because the next time we'll see each other, some of you will be in a lab with me. Uh, So we're going to look at the TFT display. I know Wayne's got a TFT display up and going this year using the Meadow board. We're going to look at it with the one of the set of APIs that come with the Cube IDE. And so we're going to wire the TFT board as shown below. And so I've put on all the different here's TFT clock and master in, slave out, master out, slave in, the chip select. And you need to name those the same way because I have configured the base level of the libraries that come with it using those names. So name it all kind of the same. As far as clock and chip select, those would obviously need to be GPIO outputs. When we look at things like master in, slave out, that is talking about an SPI interface, and we'll talk a little bit more about that coming up. And so there's all of the different pins here, and we have a few over on this side as well. Now, some are named TFT and some are named touch. So the display that we have here is a fairly inexpensive display. You're probably looking at under $10 out of China, and it's this one is based on a controller chip that's inside that's called an ILI 9341. The I think that's the one that Wayne has that you guys have been looking at. That's an ST7735, and I think as part of the labs you had to say, hey, it's an ST7735 in order to make it work, because the driver chip in behind it is an ST7735. They're very similar, and in fact, a lot of times the way the libraries work is you have to initialize the LCD and get it to come up and say, hey, I'm here, and then you can once it's initialized, then the libraries can take over and draw and put fonts and do all of that. But often the company, they don't know what display you have, and you're expected to go and initialize all of that. And we'll talk about the StemWin version in just a little bit. As far as the wiring, so here's your display, and on the back, you have to make sure that you put the orientation right because you're looking at it upside down, then you flip it around. So if I look here, I have VCC ground, chip select, and then there's a reset and a DC, and then there's the master out, slave in, and then clock and LED and so on. So you just need to make sure that you wire up the right things to the right things. Now, what I've done on this board is I've just used a little breadboard, and the reason I've done that is because this is a quarter VGA, a 320 by 240. I have a couple of other displays that have the same pinout, and so I can take this one out and put another one in, or I can take it out and test your display if you think your display isn't working. One of the things that you could do is use just female DuPont connectors and plug it in. Notice I plugged it in on the bottom. Now, some of you up till now have been plugging things in on the top, and it works okay. But these boards have been around a long time, and I wish ST would have pushed the connectors up just a little bit because these they connect, but sometimes one of them will just be slightly off. And if you're wiring up a whole bunch of things and that you have an intermittent connection, it's going to be really, really frustrating. If you plug it into the bottom, then it makes a good solid connection and you won't run into some of those issues. Even on the 3-wire temperature sensor. I've had people where it's worked and then it hasn't, or it's given weird results, and that's because the pins that stick through on the top just aren't quite long enough for those connectors. Okay, so that's one of the things. But you could just use female to female and just plug it in on the bottom of that display if you want, or if you want to be able to take off the display and test it with somebody else's, then you could use a little board kind of like this. Now, this display and the one that you use in Wayne's class, they're the same kind of configuration, but the pins aren't in the same order. I can't just take this one out and put it over on here. And so I have just jumpered over the connection so I can test out one or the other. Not to mention the resolutions are different, but we'll go into all of that kind of thing as we go. So wiring it up is the first thing, and making sure that the names are all the same. And then port Lab 5 ADC DMA to a new project called TFT. So the same way that we did it, where you copy it and then you paste it over, you rename the IOC file, you do a project clean to make sure it gets rid of all the object files, and then compile. You should have the ADC DMA working, except under a new name, and then you can go into the IOC file, add the pins that we need for the LCD, and we're on our way. Now, it says select the proper TFT connections in the IOC file, so make sure that they're named the same way I have done it, and make sure to name the pins as above. Move the STEMWin folder to your project. So the STEMWin is ST's MWin, which is a graphics library that's available for us, and we need to move it over to the project. I'll show you where all of that is in just a few minutes. On the D2L site, I have got a config.zip, and I want you to replace it with the config.zip that's in the STEMWin package. So we put the STEMWin package in the appropriate place in our TFT file, and then replace the config with the one that's there. And so what I've done is I've said, okay, for instance, I know how to initialize the ILI 9341, so I put it in the config files, and so you just have to call that. I've got probably today I'll update it because I've put a configuration for this one as well. So if you want to wire up the little display, at times you can. So, but anyway, that's all in config.zip, and we'll go over it and talk about some of the things that are in there. When you move it over, the one thing about it, so you could even in File Manager go and grab STEMWin and put it over, or you could do it from File Manager and drop it into your IDE. But if you go and compile, it won't know where all of that is. So you have to go into your IDE and right-click on Properties and add where this stuff is. Add where the include files are, so that it knows how to compile it. Not only that, but the STEMWin has the license with ST is that they don't give you the source files, they give you a library that you compile against. And so we have to point to where the library is. So we have all the header files, and if we go to step through our code, it may go, don't know where the source code is. That's because there is no source code there. ST didn't pay for you guys to have access to the source code. There's the libraries that you can go use, and there's a big manual for the APIs. And so we need to point to where the library is. And then one of the things with the library is we need to make sure it's in the right format that our IDE is going to want to do. And the other thing it says is make sure CRC module is activated. In your IOC file, there's a subcategory and it says CRC, a cyclic redundancy check. And the library uses that to recognize that it is an ST device, because it's free for you to use, even in a commercial product, if it's an ST chip. And so they do this by saying enable CRC. It is in the manual. It's when I first was looking at this, what happens is if you single step through your code, it never gets out of GUI init, the GUI initialization, because it doesn't pass the CRC, but it doesn't tell you. And so, I've forgotten to either enable it or this when I first started out with this. I didn't realize in the manual that you had to do that, it was copy protection kind of thing for using ST devices. And you go, okay, it's not showing up. And so enabling CRC will make that happen. And so if I was, for instance, using an NXP device, NXP has a similar license with the MWin guys, and I'd use the one for that one. I wouldn't use this one. And it says, by the start of Lab 7, upload a picture of your TFT screen to the assignments folder, Lab 6. It should have ESET 260 and your name below it, and the thermistor temperature, and we copied over the ADC one nicely, formatted to display one decimal place, and use at least 2 different fonts and 2 different colors. So there's an example of my board doing that. I just need yours to show something similar. Okay. So I want to look at my drive, and you'll see it says STM32Cube, Cube IDE, ST Microelectronics. So when we've installed things, so in the ST Microelectronics, that has the Cube programmer that I downloaded separately. We talked about it last day where there was, you can go and get ELF files and program it and erase different sectors and look at things with a separate Cube programmer. If other programs, for instance, their touch graphics uses the programmer to program the chips, and so it needs to have that installed if you use it. That's something we haven't used. The IDE doesn't need it because it has its own into it, but so that's the directory there. The Cube IDE has your different workspaces, okay? And every time they update the Cube IDE version, it asks you if you want to generate a new workspace. So that's kind of where your project should be, and that's where some of my projects are in here. And then there is the STM32Cube directory. And if you look in there, it says repository. And if you look at repository, so when I went and selected that I had a discovery board, it made this repository and it made the different versions here underneath. And you'll see it says Cube version 1.16, Cube F4 version 1.26, and then I also have a Cube F7 version 1.61. Well, I'm looking at Wayne's board, which has an F7 on it, and so I wanted to go and look at programming the board natively without any of the .NET. And so in order to do that, I need the base. So if I just select the chip that's in Wayne's Meadow board, it will download the packages and all the different APIs for the F7 board. We have a Cortex M4, so it's the F4 series, and it'll download the latest one. I used it last year and it was 1.16, it's at 1.26. So you go to the latest one. You probably only have one. If you have a couple, you have been updated and you use the latest one to go find it. So in this one, we'll go have a look in a sec. Some of the other things you can get are packs. And so if I went to that, I showed the last day, if you go to software and you look at some of the different things that are available, like time of flight sensors, MEMS, AI, it puts them in packs. It downloads all of them and sticks them in there. And so I'll look there. And I go to 1.26.2, that's the latest one for the F4, and we have a whole bunch of directories. So that's why it took a while when it first downloaded from everybody. There is documentation, getting started with the Cube F4, so that's in there. If I go look at drivers, we have the HAL drivers, which is our hardware abstraction layer, and that does a lot of calls on CMSIS, which is a little lower level of abstraction. Cortex microcontroller interface standard, and BSP stands for board support package. So it knows about a bunch of different boards for the F4 and all of the support materials that are there. For instance, there is the F4 discovery, different Nucleo boards, different discovery boards, eval boards. Those are about the $300 boards that before all of these Discovery and Nucleo boards came around, were really the things that people had. And then if I go into components, then there's a bunch of different components. So some of the things, for instance, there's the ILI 9341. So there's another ILI 9325. So those are TFT screens. The LIS are accelerometers, for instance. So it has a whole bunch of components that are available on some of these different boards. So there might be a driver already available. And then it's got common, so camera interface, accelerometer, audio, gyro, magnetometer, depending on the boards that you have. So that stuff is all in board support packages for the different boards. And again, we specifically are the Discovery board. That was the first name, and then they made it so that you could drag and drop and make it look like a USB file, and they call that the disk one to kind of um, uh, make a notification between the different ones. You all have the STM32F4 disk one, just the new version of the Discovery board. But it has the files for accelerometer and audio. It also has in a CHM file a board support manual giving some more documentation on some of the things with it. So that's some of the things that are in board support package, all under drivers. Then I have different projects. And again, there's projects for all the different boards. And again, we look at the Discovery board. It has applications. There's a audio application. There's something to do with EEPROMs, FATFS to deal with writing to cards. This has an audio playback and record. So there's a project in there that I can actually go in and open and compile it. And what it does is it sets up your Discovery board to play something out of the headphone and to plug a USB into the micro USB connector with the appropriate adapter. And it will, depending on when you push the blue button, it'll play back and record your voice. So that's the sample that is there. The demonstrations, this one is the one that was first on your board. When you went and saw the lights blinking and you push it and you can move it around and it'll do the accelerometer and then it'll move the mouse and that kind of thing, that's there, that project. And so you can go and import that. And then we have some examples. So if I want to look at examples with ADC, there are some small examples, GPIO, I2C, some timers, some serial ports. So there's those kind of things in there. So I'm going to go up again, and I'm going to look at middleware. And middleware, there's third party. There's the free RTOS, and then there's some networking things, how to deal with JPEGs, how to deal with reading and writing to the either USB or SD cards, for instance. And then under ST, I have, so this is the Cube middleware ST. I have different libraries for audio and for being either a USB host device, a USB host or a USB device. It also has the touch graphics libraries. So that's one of the graphics libraries that are available to you, and StemWin is the other one. The one that's the easiest to get up and going into the Cube IDE right now is StemWin. Touch graphics has a separate kind of development environment, and it uses that programmer to go and program it outside of the IDE. You can integrate it in with it, but it's not exactly seamless right now. But I want to look at the StemWin. If we go into StemWin, we have our config, our documentation. If we look at our documentation, there is the 1,300-page manual on the APIs for doing graphics. So it has the different fonts, it has how you draw circles and arcs and all of that. And so we're going to look at that coming up. Other things in here are GUI. It says simulation. So if I want to, on my Windows machine, simulate my screen and play around with development of it before putting it down to a target board, that's what some of that is all about. And then I also have software. And so there's a whole bunch of software. For instance, to remotely connect into it if I had a device with VNC. GUI Builder is about dragging and dropping, not near what you're used to, but a way of putting together an application as well. We also have some converters. For instance, if I want to convert bitmaps to C arrays that I can link in and draw special graphics on my screen, it has that. If I have my own fonts that I want to use, okay? So a bunch of Windows applications as well. So one of the things I want to do is I want to take that stem win and I want to move it over into my project directory. And then, you know, I don't need simulation because it's going to be on an ARM device, and I don't need the software, at least on my target. So I don't want that as part of my application. But I could move this whole directory over. And where I'd want to move it is into my libraries. And so if I look at, for instance, let's go to the, let's go into my workspace and we'll go TFT. And so under drivers, I dragged and dropped the whole directory in there. Okay. And so if I look in there, I got rid of some of the different directories that I said we didn't quite need. For instance, the simulation and the software, because those are Windows applications. I don't want it to take up space in my project. I might want to utilize them at some point, but I definitely don't want to compile them in there. The rest of it, I all moved over. And then documentation, I really could take that out and put that somewhere else. I don't need that to be necessarily part of my project. It's not going to link in or anything like that, but it's just taking up room in my project. But I have a config, include files. So if I go look at include, it has different header files for all the different things I want to use, drop down boxes, check boxes, buttons, all of that. If I look at OS, it says, hey, there's this file for if I am using just bare metal, no operating system, or if I'm using an operating system like FreeRTOS or something. There's an ability to have that happening in the background. There is the lib file, and in the lib file, they have a whole bunch of different files. And so you have options to do things. So these are the libraries that they have given us with no access to the source code that makes all the magic happen in behind. We have the header files, we initialize the library, then we're going to call APIs for buttons and for backgrounds and all of that. It will go into these one of these libraries. And so if you notice, they all say ST's MWin underscore, for instance, CM4. That means Cortex 4. So it's what we have. And then they have different suffixes here. So we have 32-bit in the calls. We have 16-bit. We have OT. OT stands for optimized. So it's a little tighter running code than non-optimized. They have ones that say ARGB. That stands for alpha, red, green, and blue. And so there's alpha, red, green, and blues, and there's non-alpha, red, green, and blue libraries. What it does over the base library is it swaps your red and green colors. So you have to, depending on the screen, there's a way of saying which order my colors come in. And some LCD manufacturers set up by default, you know, the green and blue, red, green, and blue, or red, blue, green, or, you know, that. And so your colors can go off. Well, they have libraries based on those as well. And so if your colors are off, it's either the library, or I'll show you where in the configuration we can just change a letter and have it swap to match. If your colors are off, it's either the library or our initialization, they're not matching. And so when I say red, I get, you know, blue or something like that. So, okay. So what I want is one of these. And so alpha, by the way, if I have alpha drivers, it's going to allow me to do various, instead of just solid colors, I can get variations of color. So I can have how solid is something, so you can see something over top of something else kind of thing, see things through different layers. But for now, what you notice, this one looks slightly different than all of these other ones. That one was STEMWIN CM4 underscore WC32 .A. I renamed it lib because the GCC compiler looks for something called lib as far as a library goes. You don't say it's lib. If you say it's a library, if you say it's a math library, I'm looking for libm.a. What it goes and finds, when I go and say I want the math library, it will look for, on the command line, if you saw it compiling, it will look for -lm. What it's looking for is libm.a. Okay, so if you just pointed to these libraries, it couldn't find them because it can't find. If I say that I want this one, STEMWIN CM4WC32OT.A, and I just pointed to it, it will try and find something called lib STEMWIN WC32. So I need to rename it that. Okay, so once I have that done, that says that's kind of up in here. Add the appropriate STEMWIN library. Okay, and then make sure that it's going to be enabled. We'll look at that. Now, let me, do I have it open? I might have it open. Okay, let me have a look at, I'm going to right click. So I've got the drivers, there's STEMWIN, there's my libraries, and I just kept them all there because I might want to choose between, but any of the ones that I think I'm going to use, I'm going to rename, and you could just rename, for instance, here, OS, any of the OS ones means you're using something like FreeRTOS. If you're not using an operating system, you pick one of the ones that are without it. So if I wanted to see what that did for me, I could go rename, and then I would just, all I do in here is just put lib in front of it. Okay, so there's a couple of them. Once we have this in there, and I wanted you to drop the whole thing in drivers, okay? And so I can shrink it, okay? So I have the whole thing in drivers. Then if I right click and I go to properties, when you go C++ build and settings, okay? If, so C++ build settings, there is things to do with the assembler, the compiler, the C compiler, and the C linker, okay? And so if I look here at the C compiler and I look at include paths, this has a bunch more include paths than you have. And so what I have up top here is it says workspace, and it points to STEMWIN include, STEMWIN config, and STEMWIN OS. And so I go into this setup, include paths, and you click the add, and then you go workspace, and you go find where your workspace is. So I'm in the project TFT SPI, and then I go into drivers, and then I go into STEMWIN, and this is saying where to go hunt for all the different includes. And so one of them is include. So I need to say, oh, okay, I want that one. Now that's the one there, but I wonder if it'll let me put two in, see? So I don't want to, but that's how you do it. And then you go add, and then you go workspace, and then I'm also going to need to include the config files. So I will go there and I will go okay, and then I'll go okay, and it'll make config, and then there was a STEMWIN OS one as well. So I do that. And then I said that there's the library that you have to bring in. And so we need to say the compiler, the the whole development environment calls the compiler, the GCC compiler. It compiles all your individual files that are on the right-hand side into individual object files, and then it calls something known as a linker, and the linker stitches all the object files together. And that's where, when you make promises, for instance, you have a prototype for a function, and then you have a function maybe in another file somewhere, you are promising to the compiler that you're going to find that. Maybe I have a variable and I made it external and I said somewhere else the variable is defined. The linker takes all those promises and says, you told me there was a count variable. There better be a count variable in one of the other object files, and I'll match up where those addresses are and make the whole thing work. Okay, and then you'll get a linker error saying it can't find stuff if that didn't work. So you may have compiled the individual files. So in this case, if I go down to the linker and look at the libraries, once again, I will go plus, and I will go to the workspace, and I'll go, mine currently is TFT SPI, and I'm in drivers, and I'm in STEMWin, and there's the libraries, and I just need it to point to where the directory is. So I go OK, and it should put that in place. Okay, and so there it is there. And so that's great. It now knows where to look for the library. And then look at the library I've picked. So I went plus there to get this, and I called it STEMWin. Let me just open this. I always forget to open this so I can see the thing when I go. Hopefully, go right click, properties. Okay. So I'm looking for the library STEMWin underscore, so capital STEM, capital WIN underscore CM4 underscore WC 32. It will look for lib STEMWin underscore WC32.A. Don't put the .a and don't put the lib. It will automatically look for those. It's like when I do include math, it's going to look for a libm.a. That's all I put, okay, just -lm, okay, just one of the quirks on GCC. All the libraries are called lib, that's what it's looking for, okay? So as soon as I do that, and then go apply and close, hopefully, then if we go and compile, things will start to compile and not give you an error. If it's talking about a library error, it's not renamed appropriately. So it's not going to link all of these in, it's just going to link in this one. Okay. And then when you go and then go to try and run it, then it will, you may get a compile error as well. There's one other thing I did in the config I should show you. In preprocessor, GCC compiler preprocessor, I made up a name. Now, I told you that there is, I put in things for the ILI 9341. I also put stuff in now for the ST7735. I also put in configurations for one known as an ILI 9488, which is just a different display resolution. Well, and it's got a different driver in it. So I wanted to support 3 different TFTs. So I put in just a name. I could have called this Mel, but seeing as it's to do with the ILI 9341, I thought that was a better name. That's known as a preprocessor directive. You can put conditional compile information in your code to say, if I have this situation, do something. It already does things like, if you're in debug, do a certain thing. You can say, if I have a TFT, so you could just put in a word TFT and go, if TFT is defined, then do the things with the TFT, otherwise go out of serial port or something like that. Okay. conditional compiles. So I've got some preprocessor directives. You have an ILI 9341. So I just want to show you a few things that need to be put in here. One thing you need to put in is all the graphics and things are going to be, you need to include the graphics headers, which is GUI.h. Okay. And so once we have that, that is going to allow us to call some of this. And down in main, we have GUI init. Now, if you are trying to single step through your code and you don't succeed through GUI init, what is probably happening is this CRC hasn't been enabled in your code. Remember I said that's kind of the copy protection they use to make sure you're using an ST product. In your IOC file, you have to go graphically. It's just a checkbox, enable CRC. Makes this work. You won't get past that if it doesn't. Okay? And then things I can do, for instance, is I can say set background color. I want my background color to be blue. GUI clear says go do it right now. It'll clear the screen and give you whatever background you have. And then I have another, this is all in that 1,300 page document that I showed you where it was in documentation. GUI set font, and then you pick the font you want, ASCII set, there's a bunch of different fonts, a bunch of different sizes that are all there. It's kind of funny, some of the ones in the book, some of the ones in that 1,300 page document don't exist. They're in the MWin document, but maybe ST didn't license all of the fonts or something, so some of them aren't there. And basically you don't see anything displayed, pick another font. GUI set color, GUI yellow, and here's the preprocessor directive stuff I wanted to talk to you about. So if I only have one screen, I don't have to put in any preprocessor directives at all because you're only supporting one screen, who cares? But I was supporting a bunch of different screens. So here is my hash ifdef. So right there, we have hash ifdef. So I defined in the properties, in the preprocessor directives, ILI 9341. So I can say, if you have defined a word, you can also say stuff like if defined ILI 9341 is less than 5, if I defined it as being equal to 5 or something. But in this case, I just want to know that it exists or doesn't exist. And so I said, okay, if you've defined it somewhere, if that exists, then put into the C code this stuff. If it doesn't exist, then does elif defined ILI 9488, then put this stuff in. Otherwise, if it's something else, and I said it's going to, I just commented out, it's going to be the 7735, then put this stuff in. So you notice this is green, it's shaded out. So it's telling you it's not part of the code right now. The preprocessor said, this is the code that's in here. The things that don't make it are grayed out. So the only code that's in here right now, in this part between the ifdef and the endif, is these two lines here. These are conditional. The C compiler doesn't see them. They're not there, okay, as far as the C compiler is concerned, because the preprocessor went and decided what code was actually going to be there. Quite powerful. You can do something like debug. You might have long delays or something. And when you're testing stuff, you don't want it to run. Or again, if you have 2 different types of displays or 3 different types of displays, look at the difference in them here. This says GUI display string horizontal center at, and so I'm saying the screen is 320 by 240. So if your screen is 320 by 240. I want you to display a string called ESET260. I want you to center it around 160. Well, 320, 160 is in the center, and it works out what font you have, how much space it takes, and centers it up for you. Okay, and then 50 down. So I'm going to go over 160, I'm going to go 50 pixels down. GUI display string 8 center at Mel Dundas 160, 100. Again, start it there. I don't know how many words are in my string. It'll work it out. You don't have to. And then it'll center it. Now, just if you don't want it centered, just go display string at no horizontal center, and it'll start there and continue from that location. Okay, those are all in that document there on writing text. Well, look at what I have on my preprocessor. The 9488 is 480 by 320. So what I want to do is to center it up is for 480, half of it is 240. So I just needed to say that it needs to go a 90. This is a ILI 9341. An ILI 9488 is 480 by 320 on my display. Do you guys know what your ST one is? Yeah, so 128. So if I define that one, of course, if I was trying to write at 160 here, it would be well off the screen. So if it's the ST7735, you know, I have, I want it, it's 160, so I want it halfway at 80, and it is 120, you were saying? 120 by 160, right? Yeah. So then halfway is going to be 80, halfway is going to be the 160, halfway is going to be the 240, depending on the displays, because I wanted to support all those. So it'll change. If I go through here, let me just go in the preprocessor directives again, and I go properties, and I say, what did we say? ST7735, but that's going to trigger it in my else statement, I think. So apply. You can also put else and type an error message that says you need to select something. So you can have that kind of thing happen. Well, look what happened. It grayed out the other ones. So now it's going to compile this into my code, the bottom one. Okay. So that's kind of the power of preprocessor directives in doing this. Okay. So let me put that back. Properties. ILI 9341. So again, the config that comes with it, I've modified the config to put in support for our screens. So you need to just replace in drivers once you go and bring it here, our version that's on the site, on the D2L site. And then we'll just compile it, although I think I may have done it already so that you can see it. Oh, that's the other one. So we have something I got. Now this one is the lab after, in which case I want you to interface the touch screen and all of that. Okay. So you're wiring all of it up right now, but if we go look at our on this one, I don't have the touch screen kind of wired up. I didn't put those extra little lines on the board. TFT is all the wiring you need to make the graphics display work. Any of the touch are the lines that you need to make the touch screen work. And the touch screen is an overlay. There's a resistive overlay on top. Now this is also, I've also got this just little plastic, so it's not that. You can take that one off, but there's a little resistive overlay panel on top of that. And when I touch various places, it's going to show up where you're pointing and activate with buttons and things like that. So there's two different things. There's the screen and there's the resistive overlay. that is on this. This little board that you have from Wayne, it doesn't have the touch interface, but you see there's some pins that are open. That's because they could have wrapped a touchscreen overlay on this as well and given you that. You can buy some of them like that as well if you want to do some of those kind of things. Okay, for the first part, as long as for the week 6 lab, as long as the TFT ones are wired up, you're good to go. The other thing that a lot of these boards have on them as well is an SD card reader. And so that's separate, and I didn't want you to have to go and wire it up. I have used them in the past, and those are wiring there, and it goes to this card there. And your ARM board does support reading and writing. We pointed out that it has the FAT file system, so you can write stuff to directories on a SD card, for instance, so you could do data logging. And it just, most of the kind of little from 2.4 up on screen seem to throw in an SD card interface just because you might have graphics that you don't want to store on your microprocessor. You can store them on the SD card and load them in and display them and things. So it didn't cost them much to fire that kind of on there. Okay, so hopefully I've given you enough to start off. You need to get StemWin, find it, stick it over there, get rid of any of the, like I say, the Windows applications. When you go and compile it, again, put our version of config. Next day, I'm going to go and we're going to talk a little bit about what's in config, mainly LCD config is what we needed to tailor to our screens, and that's where it has the initialization of the drivers and things for that, but that part is done for you. You're going to have to reference that manual that's in the documentation to make some of this stuff happen. Thank you very much.